morning, everybody. Welcome to our second Fossil Finds program of this new school year. To view live closed captions in English and Spanish, please click on the external link we will drop in the chat. For our guests watching on YouTube, the link to closed captions in English and Spanish is in the video description below. We're so glad to have you with us this morning for an up-close look at some of our favorite fossil finds discovered right here in the middle of Los Angeles. My name is Agnes, and I work with the education team at the Brea Tar Pits. And today we'll have the opportunity to chat with one of our excavators, Sean, who will be joining us from Project 23. I'm joined off screen by my colleagues, Rachel, Cassie, and Jules, who will be helping to organize your questions. Thanks so much, team. But before we get started, I want to share a little bit about what you're going to do with us today. So we're going to be together for about the next 30 minutes, and we'll discuss one of our favorite fossil finds. After Sean is done sharing, we'll answer some of your questions about the fossil. So this time, Sean will take us into Project 23 in Hancock Park to talk about pumas. And there he'll share his fossil find and help explain why those big cats survived the Ice Age and why they're still around today. This might be a different format of Zoom than some of our students joining today are used to. You won't see any of your classmates, your teacher, or any of the other people watching the program today. And we cannot see or hear you. You'll only be able to see and hear us. So since we can't actually see one another, I do want to take a moment to make a shout out to students joining us from all of today's schools. Welcome, everyone. Since we can't actually see any of you and you can only see us right now, we're going to use the chat function to ask questions. During the presentation, you can click on the chat box, type in your question, and Sean will answer as many as possible during our Q&A session at the end. Your chat box might look a little different depending on what device you're using now, but the icon looks like the one that you see on the screen that says chat. So your question will only be seen by the museum staff who are running this Zoom right now. And the chat box is currently closed, but we will open it up when Sean is doing his presentation. And we do ask that all of our friends joining us today only put questions or comments related to the presentation in the chat. This helps us make sure we get through as many questions as possible. To respect our panelists and our staff assisting with the program, we also ask that we all use appropriate language in the chat. Folks not following our code of conduct may be asked to leave today's program. We'll try to get to as many questions as we can, and Sean might even answer a lot of them during his presentation. But if we don't get to answer your question today, I encourage you to write it down so you can learn more about the animal on your own. So if you'd like, go ahead and grab a piece of paper and a pencil so you can record your experience while you're watching today. You can note down any of those questions you have, maybe a few fun facts you learned, or draw a right description of what the fossil looks like. So here are some vocabulary words that you may hear this morning. Feel free to jot them down or grab a screenshot so you can review them later. So as I mentioned earlier, we're going to be joined by Sean Campbell today. He is one of our fossil preparators at the museum. So let's go ahead and get started. I'm going to switch our camera over to Sean so we can meet today's Ice Age animal, and you'll see me again in a little bit. Hi, Sean. How are things out to Project 23 today?
It's going well, yeah. So here we are in box 13. So box 13 is part of Project 23, which was a salvage operation. So the art museum next door dug an underground parking structure in 2006. They found all these new deposits and fossils, and box 13 was the 13th deposit found in that year. And we've excavated about half of it. And we found thousands and thousands of remains of many different types of species and organisms, including Puma concolor. So we're going to be talking about mountain lions. And this is a 3D replica. So one of my coworkers, Carrie, scanned the real skull that was found in this box, and she 3D printed it and made this replica that's exactly life size, which is really cool and great for educational purposes. And this mountain lion was named Pebbles from an elementary school in Linwood when school programs set up a little event to have a naming competition, and they found rocks in the nose of Pebbles, and they said, Pebbles is a cute name, let's use that. So we're gonna go into the slides and talk about pumas of La Brea in Los Angeles. So here on this slide, we see multiple photographs taken of fossil specimens that were found right here in box 13, where I'm sitting right now. So you see two large images of the skull. So on the right side, you'll see that it's a dirty fossil. So that was the day that it was removed. We excavated it out with dental tools and chemicals, and we found this amazing skull, and we knew right away that it wasn't a dire wolf or a saber-toothed cat, things that we find a lot of, and that it was something different and kind of a little bit more special for us because we don't find a lot of mountain lions at the Brea Tar Pits. And then one of the fossil preparators in the lab, Stephanie Potts, actually cleaned the specimen so you can see it on the left-hand side. And now that specimen sits in our collections waiting for researchers to study and analyze it. And there's a couple other photos. So there's a ulna on the bottom left, which is a forearm bone. And when we pulled that out, we knew exactly what it was because it was very different, very oddly shaped, very different from a dire wolf, even though it was about the same size. It was much more robust, and cats have very, very large arms to tackle and subdue prey. So we knew that was a mountain lion right away. And this all seems to be one individual coming out of this deposit, which is really incredible. And then on the bottom right, you can see a vertebra, which is a backbone. And that vertebra, when it was originally found, it was caked with all the matrix or the sands and silts and clays and tar and asphalt covering it. So it was about the same size as a dire wolf. So out here in excavations, we thought it was probably a dire wolf vertebra. But once they cleaned it and the collections managers used comparative, they were able to identify it as a mountain lion vertebra. So we have a lot more to excavate in this deposit, and we hope to find more and to see how dispersed and spread that mountain lion is in this deposit. And we're going to move on to the next slide. So at the Brea Tar Pits, we are inside Hancock Park. So this was a park donated to our museum in the county back in the early 1900s, and it's about 23 acres. Around 130 deposits have been excavated over the last 100 and more years, and only 16 of those deposits have found Puma or mountain lion remains. And there's only slightly over 200 individual bones that have been identified as Puma from all of the collections of La Brea fossils. So we have millions of fossils in our collections. And for instance, dire wolves and saber-toothed cats, the individual bones that represent those species, there's hundreds of thousands of them. There's so many of them. But for mountain lions, there's only a couple hundred essentially. And so we're going to move on to the next slide. And to show you what those specimens look like when they're completely cleaned and put into storage, this is in the collections, and there's a bunch of drawers and a bunch of aisles that contain the millions of specimens that we have at the La Brea Tar Pits. There's only a few drawers of mountain lions, and this is one of them that I pulled out because it's the only other complete skull that was found in the early 1900s. And then various other dentaries or jaw bones and teeth and all sorts of other things in that drawer. And then other drawers right next to it contain all the elements that have ever been found of any mountain lion at the La Brea Tar Pits. So we're going to move on to the next slide. And I'm going to talk about the evolution of the Puma lineage. So Pumas are actually more closely related to house cats than they are to the true panthers. Things like lions and tigers and leopards, those are panthers and they're separated. Those are big cats. And so pumas are essentially the largest of the smaller cats. So they don't roar, but they do purr and things like that. So Felis sylvestris is actually an example of the species of house cat. And then Asionix jubatus is the cheetah. So cheetahs are actually very, very closely related to pumas. And they separated about 5 million years ago, and they only live in the old world. And then getting closer to the pumas, there's the jaguarundi, which is the closest living relative of pumas today. So they live mostly in Central and South America, but sometimes they'll wander as far north is Texas. And that's actually in the Puma lineage, so that genus is incorrect on that picture. And then, but they separated about 4 million years ago from pumas and became their own thing. And then Miracyonyx trumani is a species of what's called the American cheetah-like cat. So originally, when they found these specimens of Miracyonyx, scientists thought, oh, this must be a cheetah that came into the New World. But based on genetic evidence, we actually found out that Miracyonyx, or the American cheetah-like cat, is more closely related to pumas, and they separated from pumas about 3 million years ago. And it's what we consider convergent evolution. So they evolved and adapted to hunting extremely fast prey, the pronghorn of North America, and they developed extreme speed. And that's one of the reasons that the pronghorn is one of the fastest animals on the planet, even though there's nothing living in North America today that's nearly as fast as it. It's because it's a relic of the evolution arms race between the American cheetah-like cat and the pronghorn. But the American cheetah-like cat went extinct at the end of the Pleistocene. So the time frame that we're excavating here at the Brea Tar Pits. And then obviously there's Puma concolor. So pumas, based on the most recent genetic evidence, seem to have originated in South America and then colonized North America later on. So they originated a little over 1 million years ago, and the oldest fossil is about 1 million years old that was found in Argentina. And then the oldest fossils in North America are much younger. And scientists think that they came into North America about 300,000 years ago, based on the genetics. So we're going to move on to the next slide. And on the left side, you see a map that represents where pumas have been found historically in the historical record versus modern day, which is where all the red is. So you can see that all the way up in Canada down to the southern tip of South America, you can find mountain lions or pumas. And they're one of the most widespread animals on the planet, especially quadruped animals, which just means they're running around on all fours. And you can see that historically they went all the way to the East Coast and took up all those habitats. But once Europeans arrived, they started kind of eliminating and hunting them, unfortunately, and completely eradicated them from the eastern portion of the United States, except for in Florida, where they're called the Florida panther. Remember, they're not panthers, but that's just a moniker that they've been titled. But they're mountain lions that have been able to hold on in Florida, but they're very inbred populations. So anyway, on the West Coast, they're actually doing fairly well in certain areas. Wherever it's very urban, like Los Angeles, they're not doing as well. But in large open expanses, they're doing okay. They're doing all right. And then we're going to talk about the habitats. So with all of that space, the southern tip of South America all the way to Canada, there's a ton of different habitats and ecological zones that the pumas can exist in, and they exist in pretty much every single one. They're really amazing creatures. So from sea level to about 15,000 feet in the mountains, like places like the Andes in South America, you can find mountain lions. You can also find them in tropical rainforest, temperate forests. You can find them along rivers and next to lakes. You can find them in snowy areas. They love hunting in the snow. You can find them in deserts. You can find them in grassy plain areas, but they don't really like open environments because these animals, these mountain lions, they don't have a great lung capacity and they don't have a great endurance. So coming across other predators that could be competitors that might be able to hurt them or maybe even kill them, if they're caught in the open, they're not likely to be able to escape and run away, because although they're pretty fast, they can run over 40 miles an hour. They can't keep that up for a long period of time. So a pack of wolves would hunt down the puma and potentially hurt it. So they don't like to be in open areas. So usually they're not in prairies or grasslands unless the grass is really, really tall. Then you might be able to find them hunting, or they might be passing through an area, but they usually like closed environments, forested, or they like rocky outcrops where they can jump up and hide in rock formations and things like that. And we're going to move on to the next slide. And there's been a lot of fossil research that's been done at the Brea Tar Pits. And most of this research has been done by Dr. Larissa DeSantis, as well as all the members of her team, and a few other scientists as well. So the top left is a picture of a dentary or jawbone that was, you can see a little rectangle was excavated out, and they pulverized that and processed it and analyzed it. And they've dated a couple specimens using radiocarbon, and the two specimens that came out from the early 1900s were about 28,000 years old. So the Puma found in box 13 is probably around the same age. We haven't dated the specimen directly, but other specimens found in this box were about 32,000 years old. So it might be the oldest dated specimen if we ever date it individually, which would be really cool, found at La Brea. And then the carbon isotopes, you can also do, you can look at the radioactive carbon and kind of tell what it was eating and what types of environments that it liked. So they did this, and they found that the pumas were in a negative radiocarbon isotope ratio. And it essentially just says they like closed environments, they like eating things in closed environments. Closed just means heavily forested in areas like that. And they're eating, the prey items are eating certain types of plants, and they can tell a lot of it based on that. And then on the bottom, there's something called dental microwear. So they'll find teeth from fossil specimens, and they'll scan it and make large, they'll magnify it a lot. And then they'll look at the pits and gouges and scrapes and scratches. And by doing this, they can tell, did it eat just flesh? Did it have to resort to eating bone at all? Or did it scrape bone because it was really scavenging every morsel off of it could off the remains? And when they did this to modern mountain lions, as well as the fossil mountain lions found at La Brea and other locations such as Santa Barbara Natural History Museum, they found a scatter plot that's all over the place, and all of them are everywhere, and they're all kind of doing various things. Because the diet of mountain lions is very versatile. So they can eat things as small as little rodents all the way to something twice the size of itself, like large elk, and then even juvenile moose and things like that, depending on exactly where they live. So, and then they mostly like to eat deer and elk and things like that, which we had at the La Brea Tar Pits. We find those in the fossil record as well. And then based on the dental microwear, they were processing the bone a little bit because we know they eat smaller things. And you can actually find rodent bones in the scat or feces of mountain lions today. And that was probably true in the past as well. And now we're going to move on to the next slide. And so what paleontologists do very often is they'll try and find what's called a modern analog, an animal that is either doing something that's very similar, living in the same sorts of habitats and eating the same sorts of things, or in the case of something such as a mountain lion, they still persist, they still exist. So that's something called extant. So if you've ever heard of extinct, that means the species is gone and you can't find them anywhere in the world today. Extant is the opposite. It means you still can find them. So even though we have the ancestors of the mountain lions in the La Brea Tar Pits in the fossil record that lived thousands and thousands of years ago, you can also find modern mountain lions. And so biologists study them. And this is a great record for paleontologists to work with biologists or read their work and infer what was going on in the past based on all of that. So some really cool, interesting facts about mountain lions that biologists have uncovered is that the young, the cubs or kittens, they're stashed in nurseries or dens, and they have lots of markings. So they have stripes and spots, and they even have rings on their tails. And scientists have argued about why the mountain lion, when it's an adult, is essentially one color or a uniform color, which is where the species name concolor comes from. And why do the adults have one color essentially, or two colors because they're light on their bellies? And why do the kittens and cubs have all these stripes and markings? There might be various reasons. So one, the evolution of the animals cats, the ancestors seem to be the ancestral mode. They have lots of stripes and markings and spots, and so it might be a relic of evolution. But then also, the young are well camouflaged by all these markings, so it might be that. And then also, markings form a sense of communication between animals that's non-vocal. So when you see markings on a young puma, it identifies them as a juvenile or a youngster, and they don't lose their markings until essentially they become an adult. So like about a year to 2 years after they're born, they'll lose most of their markings, and then they'll become an adult and migrate away from their mothers. And so, but when they're living with their mothers in their mother's home range, the markings can say to other animals, especially male pumas, hey, I'm a youngster and I'm of no threat. And that potentially might be able to help them a little bit as well. So if we look on the right side of this slide, we see eyes of mountain lions, which is kind of cool. So the very top is a youngster's eyes. So if any of you have had cats, modern day house cats, you might have noticed when you got them when they were really small kittens, they might have had really blue eyes. But then that changed later on. And that's because in cats, including pumas, the genetics determine the eye color. But when they're first born, they don't open their eyes to about a week to 2 weeks after birth. And the genes haven't turned on to put pigment in the iris of the eye. And so when they're born, they have colorless irises or eyeballs. And the blue is actually light refracting out of the eye. It's how the light is refracting out of the eye that creates a blue color. And then you get, hi Agnes, we have a couple minutes left. Okay, so, and then you get more and more pigment, and so it becomes a yellow amberish color as they get older. And then at the very bottom, they have reflective tissues behind their retinas. And so that's called eye shine, when you see their eyes shine in the dark. And many different nocturnal animals have this, and it helps them see 7 times better than humans at nighttime. So it really helps with them hunting. And we're going to move to the next slide. And they have really large, extensive home ranges. So male mountain lions will have really big ones. So they can be up to 300 square miles. And the females will have smaller ones. But it all depends on where they're living. So if they live in an urban environment, they may have very small home ranges because they just don't have enough space to spread out. But in vast areas, they can get as large as 300 square miles, which is huge. So there's very few of them on the landscape, which is why we have so few of them in the fossil record. It's because there's not a lot of pumas on the landscape at any one time. And then they make scrapes or markings with their hind feet along in their territories, and that signals to other cats to stay away from them, and this is their territory and this is where they hunt. And then it signals to females, hey, I'm a big strong male and maybe we should mate and breed and produce young. And then the females will actually check out their markings that sometimes have urine and feces in them that leave scents and clues, chemical clues to their fitness. And then moving to the next slide, we have humans have interacted with pumas and mountain lions since humans have been in the Americas. And the Native Americans and their ancestors, they have interacted with them the whole time. And they've even made petroglyphs and markings displaying mountain lions. And some of them thought of them as gods or even considered them a part of their cardinal direction for how they orient them in their world. And some of them thought of them as mischievous or nuisances. So because there's a diverse population of peoples that have lived throughout all of the Americas, there's a diverse viewpoint on mountain lions, and it's very diverse. And then when European arrivals came, they essentially thought of them as a nuisance and hunted them down and have set bounties. And even former president of the United States, Teddy Roosevelt, went on a puma hunt and killed 12 mountain lions in one season, which is a little sad. So even though Teddy Roosevelt did amazing things like set up the national park system and things like that, he also was a big hunter and hunted a bunch of pumas, which is kind of sad. But the bounties are essentially eradicated from North America for the most part. You're not allowed to hunt mountain lions unless you have special permits, or if they're doing something bad in a farmland or agricultural area, then there's predation permits that you can get. But for the most part, we focus on protecting these native species and wildlife now. And then moving to the last slide, we have a P22, a mountain lion that was discovered by the museum, one of the museum staff members. So Miguel Orellana found P22 in Griffith Park right here in Los Angeles quite a few years ago now. And so that mountain lion is all by himself because he crossed a bunch of freeways to get into Griffith Park, and he's probably going to stay there for the rest of his life. And he probably can't find a mate or breed because there's no other pumas in that area. And so freeways are a huge problem. So urban areas are a huge problem for mountain lions because they have these huge territories and they like to really go out into different areas. And the freeways kind of bisect and go over all of their territory and really cut them off and makes their ranges much, much smaller. So there's a lot of different institutions and entities and peoples trying to create wildlife overpasses. And there's a really big one that's going to be in Liberty Canyon. And they've already collected over $70 million. And they're going to make an amazing new wildlife overpass that's going to help pumas as well as many, many other wildlife cross over the freeways and create a safe passage for them so that they can find mates on other sides and have access to a larger amount of area to find prey.
Wonderful. Thank you, Sean. Thank you so much. That was fascinating. So we have a lot of questions from our students here. Couple of students, Taylor and Carson, are asking, how do you clean the tar off the fossils? You showed a picture of them covered in that. So how do we get them clean?
Yeah, so when we excavate, so we have a fossil and something like a dental tool, we'll use a little bit of chemical to soften up the material. And then we'll use a dental tool to remove the sands and silts and clays and asphalt surrounding the fossil. And then once we measure it out, we send it to the lab. And inside the laboratory, preparators inside the lab will use more chemicals and foam tip applicators and soft tools to clean off the rest of the sediments and dirt and things like that, as well as most of the asphalt, but not all of it, because we want that tar to remain on the specimen, inside the specimen, to solidify it and sort of make it better preserved, because it's been preserving the specimens amazingly for thousands of years, and we want it to continue doing that.
And that kind of goes on to the next question from Lillian Taylor. I'm assuming it's easier to see what the fossils are once they're cleaned, but how do you tell those fossils apart, and how do you know it's a puma you've found? Do you know it? They want to know if you know it the second you see it, or do you have to do research on that fossil?
Sometimes we know right away after we have exposed it. So exposing just means we excavate around it so we can see all of the features and anatomical points. So sometimes when it's a really nice complete specimen and something that we're pretty familiar with, we know right away what it is and we write it on the card. But the card is a tentative identification until it can be fully prepared and cleaned. And then a collections manager will use comparative material, which just means they use already identified bones and remains, and then they compare it to what we found in the excavation site, and then they can identify it based off of that. So when we found the mountain lion, at first we thought it was probably another dire wolf because we just found the back end of it, and then we found more and more and more, and then all of a sudden the snout ended very abruptly. And so we knew it was a cat immediately when we saw how short the snout was, and based on its size and how complete it was and that it was an adult, we assumed that it was probably a mountain lion, and we went over to the comparative, and then we looked at modern mountain lion skeletons, and we confirmed, yeah, hey, this is a mountain lion. But like the vertebra that we found, we didn't know that that vertebra was from the mountain lion based on its size, and that we didn't have it fully cleaned. We thought it was a dire wolf or something because it was about the same size. So we don't always know right away, but we figure it out eventually if we don't.
Perfect. And then a couple of students are asking about P22 and the pumas that are around today. So what do they eat? You mentioned a little bit about what their diet is, but what does P22 eat? And are they nocturnal? And when would P22 be out and about in Griffith Park?
So mountain lions and pumas are not exclusively nocturnal, but they prefer to hunt during what's called crepuscular, so dawn and dusk, and nighttime, so nocturnal hunting. So they prefer that because the adaptations for their hunting, like their eyesight is much better at night. And so they're really good at hunting at night. So that's when they prefer to be active. But that being said, you can see them during the daylight, but not all the time. Usually they like to be active at night. And then what was the other part of the question?
Their diet. What would P22 eat in Griffith Park?
Yeah, so P22 eats all sorts of stuff. So mountain lions mainly like things like deer and elk, depending on what's available. And then like in places like South America, they like things like guanacos and llamas and things like that. But in LA, they like deer, and then they like smaller creatures, and they eat carnivores too. So they'll eat things like skunks and weasels and all sorts of other things. So as small as a little rodent, they'll eat all the way down to that. But they're hyper carnivores, so they only eat other living animals, and usually they're other vertebrates. And sometimes they'll even eat lizards and things like that. And so it's a huge variety of things that they like to eat. But mostly, if they can get it, they'll want to tackle deer.
Perfect. Bigger the better, I guess, for them. Yeah. More to eat.
They're one of the only animals that can take down something twice its own size. So, like certain biologists have seen remains as well as active hunting of like small moose as well as really large elk that are twice the size of pumas, which is pretty spectacular that it can eat anywhere. And that's why it persisted and existed from the Pleistocene to modern day, most likely, because it has a range of habitats. It can live pretty much anywhere, and it can eat almost anything as long as it's another animal. So that diversibility and variability probably did them very well for living through the extinction event that killed off saber-toothed cats and dire wolves and things.
That's impressive. Smart cats. Very smart cats. And so we're going to end now, Sean, but I do have one last question for you, because this is our very last fossil finds, at least of this year, until maybe we do them next year. But everybody always wants to know, what's your favorite fossil that you've ever found?
Pebbles is one of my favorite fossils for sure. So the probably my favorite fossils have come out of box 13. So I've been working in box 9 for a number of years now. So we're finding amazing specimens over there and really interesting geology. But as far as animals and specimens, my 2 favorite ones is pebbles. And then also there was a baby mastodon that we found in box 13. And it's so juvenile that the tibia and femur were only about this big. So it was a very, very small, tiny little mastodon. And that was amazing to find. Yeah.
Fabulous. Well, thank you, Sean. Thank you for spending your morning with us. We really appreciate it. Hopefully we'll see you again soon. Take care.
Bye.
Bye. So thank you everyone for joining us this morning. We learned so much about pumas. And if you want to see more from our fossil preparators, please give them a follow on Instagram at Brea Tar Pits. And we'll also have all of these videos from these presentations on our YouTube channel for you to watch later. And you can catch this recording and others at youtube.com/the Brea Tar Pits. So we hope to see you again at the end of this month when we do Inside the Fossil Lab. But that's going to be it for our fossil finds until possibly the new year. So thank you again for joining us, and enjoy the rest of your day.